So let us write them up. Radio frame 10 millisecond. Subframe 1 millisecond. And symbols per slot. This is also same, 14 in all cases. Now, an important thing here is the symbol duration. What is the meaning of symbol duration? So how do you calculate symbol duration? So we have 1 divided by 15 kilohertz. 15, 1, 2, 3 kilohertz. So this is the useful symbol duration, 66.67 microseconds. And in this, I will multiply this with 1, 2, 3, 4, 5, 6. So to make it in nanoseconds. So these microseconds, right? So this microseconds plus I'm going to add 4.76, which is the 4.76, which is the symbol duration of the cyclic prefix, right? Now for this case, it would become half of it. Right. So now it is same. Okay. Cool, right? Perfect. So you can compare them with here 71.43 microseconds, 35.71 microseconds. So this makes it the overall symbol duration, right? Okay. But let me tell you, all these are in microseconds. All these symbol durations are in microseconds. And this subcarrier frame is in milliseconds. Right? Remember this. 10 milliseconds. Okay. Now, let us see in one slot. So what will become our slot duration? Yes. Next is to identify the slot duration. Look at this. So in one slot, how many symbols are there? 14. And what is the symbol duration? This. So what will be my slot duration? Very simple. This times 14. Could you see? And they're all in microseconds, right? So if I have to make them in milliseconds, what do I need to do? I need to divide this term by 1000. 1, 2, 3. So here we go. Yes, they have kept it in microseconds only. So let us also keep them in microseconds only. Okay. Now we know this. We know this. We know this. We also know this. And we also know this, right? So what is the next thing? Slots in one subframe. Slots per one subframe. How much will be the slots per subframe? So what is the size of one subframe? Subframe is all 1 millisecond. So what is 1 millisecond? 1000 microseconds, right? So let us do this times 1000 divided by this term. Okay, so this is called as slots per subframe. So in one radio frame, how many slots will be there? Obviously, that will be 10 times of this. So if one subframe is 1 millisecond, one radio frame is 10 millisecond. So slots per subframe is 1. So slots per frame will be how much? This times this. This times 10, sorry. This times 10. So it is going to be like that only. This times 10 because 10 subframes makes it one frame. Slots per frame. So I hope now this calculation makes it easier for you to understand everything. Important thing here is to know that these different subcarrier spacings are supported for data. Okay, so they are supported for the data and these are supported for sync signals, right? So different types of subcarrier spacings are available here. I'm sure everything else is now clear. An important thing also to understand is that what all are different bandwidths which are available. So the 5G can start from as small as 5 megahertz of bandwidth and it can go up to as big as 400 megahertz of the bandwidth. But remember this, 400 megahertz are only possible for frequency range 2, right, which starts from 50 and goes all the way up to 400. But FR1 starts from 5, go all the way only up to 100 megahertz, right? And which all subcarrier spacings are possible and how many maximum physical resource blocks which are available is explained here. So this table is from 3GPP specification 38.104. Okay. Now next part is the physical channels which are available in 5G. So just like LTE, physical channels are almost same, but the number of physical channels have reduced. So we have physical downlink shared channel, which is used for the purpose of carrying the data, plus signaling. Then we have physical downlink control channel. So this control channel basically carry the scheduling grant for both downlink as well as uplink, right? That means before you access PDSCH or before you access PUSCH, in order to transmit or receive data, first you need to read PDCCH, so that PDCCH will tell you where exactly you need to decode your PDSCH or PUSCH. All right. So I hope that is clear. Then next we have is physical broadcast channel. As the name suggests, this is used for broadcasting the master information block, which is a very vital information required for the user to get synchronized and connected with the network. Then we have physical uplink shared channel. This channel is used to send the scheduling request indication. So scheduling grant obviously will be given for uplink also in PDCCH, but how will you get the grant? That request will be generated by PUCCH. Then we have another channel called PRACH, physical random access channel. This channel is basically used to access the network, because before you access the network, you perform cell synchronization, you perform cell selection, you start reading MIB and SIB1, etc. All these things are happening in the downlink direction. So whenever you are reading the uh, system information or broadcast information, that means everything is happening in the downlink direction, wherein the network is not even aware whether the user has selected him or not. So physical random access channel is the first channel which the UE is going to use in order to first uplink channel in order to get access on the network. Therefore, in our training at the last chapter which is there, we are going to do RSI planning. So RSI is nothing but how the PRACH from one cell will be differentiated by the PRACH of another cell. This is what is the major idea of the PRACH channel, right? Modulation schemes which are available, it also support 256 QAM in the downlink, as well as 256 QAMs are supported